All right, let's continue with this quiz review. Going on to the next odd. Remember, these I'm still using norm CDF or inverse normal depending on what the problem asks for. So in number 5, the speeds of cars on the highway have a mean of 95 kilometers per hour with the standard deviation of 5 kilometers per hour. In part A, I'm asked probability. Probability is the same as proportions here. So what proportion of cars average less than 85 kilometers per hour? So same wording there. Let's draw my curve. The mean here is 95. It's in the center. Standard deviation is 5. I want to know the proportion less than 85. So 85 is somewhere down here. And I want to find that area. So this is a norm CDF again. So we're going to go norm CDF. Second Bears. And the furthest left my shading goes is negative George Sink. Right, it's shaded forever to the left. The furthest right it goes is 85. The mean here is 95 and the standard deviation is 5. And I get 0.023. Or you can leave it a decimal, or you can make it into percent. That's 2.3%. So 2.3% of cars drive less than 85 kilometers per hour on this highway. Part B is similar. If a police car stops cars that were going more than 105 kilometers per hour, how many cars would he stop if there were 8,000 cars on the highway? So I'll sketch my curve again. I have a little bit more space this time. 95 is in the middle. Same mean, same standard deviation. Now I want more. We're going more than 105 kilometers per hour. So 105 somewhere up here. And more means shade to the right. So I'm at another norm CDF. So I got a second Bears. Normal CDF, number 2. My lower bound, the furthest left my shading goes, you can see in my picture, is 105. So that's my lower bound. My upper bound is going to be George Sink. And my mean and standard deviation are there, and they're correct. So I get 2.3% again. That's crazy. Oh, it's because it's proportional. Or symmetric. So my percentage of cars going more than 105 kilometers per hour is also 2.3%. And you can leave it as a decimal or you can make it a percent. Actually, we're going to leave it as a decimal because I want to find the number. 8,000 cars were stopped. I'm going to multiply that by 8,000. And I get the number of cars to be 182. So 182 cars would get stopped for going over 105 kilometers per hour. All right, the last odd on the practice quiz is number 7. A grading scale is set up for 1,000 students' test scores. It is assumed the scores are normally distributed with a mean of 75 and a standard deviation of 15. If 60 is the lowest passing score, how many students are expected to pass the test? So let's think about this by drawing a picture first. So if I sketch my curve, the mean is 75. The standard deviation is 15, so 75 is here in the middle. Passing score is 60, so 60 obviously is below the average. That's right here. So to pass, you need a 60 or more. So I'm going to shade the right side of my curve. So I need to find that area or that percent. And then after I find that area or percent, I'm going to do it for 1,000 students. So guess what? Back to the calculator for another normal CDF. Second Bears, we pick option 2. So now the furthest left the shading goes is 60. The furthest right it goes is forever to George Sink. Oh, this is 75 now as my new mean, and my new standard deviation is 15. And I get 0.841 or 84-ish%. So 0.841. I'm going to multiply that by 1,000 because there's 1,000 students taking this test, or 1,000 students that took this test. And that's easy to calculate. I just move those decimals 3 times. I get 841 students. All right, part B, finally, an inverse normal. And right away I know it's inverse normal because this top 5%, I'm given a percent. So if the top 5% of scores get a homework pass, what is the lowest score capable of receiving a pass? So start with a picture. My mean's in the middle. And top 5%. That's going to be way up here somewhere, right? Top 5%, the best of the best. So I need to find, that's a question mark there, I need to find what is that value. So if I'm given a percent, meaning I'm given this percent is 5%, or as a decimal that's 0.05, this is when we pick inverse normal in the calculator because we're working backwards. So we're doing the opposite of what we've been doing. We have an area, we want to know what is this question mark. So I go to my calculator, second varies again, but this time I'm picking option 3, inverse normal. Now the area. So we talked about in class, the area our calculators understand is left area. So if you notice, this 5%, if you look at my picture, is on the right. I can't use that. I need this area on the left for my calculator. Well, not a big deal. I know the whole area is 1. So if that's 0.05, that means what's left over, where my little cross is here, is 0.95. So I'm going to use 0.95 for my area because that's the area to the left. So in my calculator, I'm going to use area of 0.95, 0.95. Got to use a decimal. Calculator doesn't like percents. The mean is 75. And my standard deviation is 15. Enter. I get 99.67, or let's just say 99.7% gets a homework pass. So you got to almost be perfect. I'll write my steps here. So that was inverse normal. The area we used was 0.95. My mean is 75. My standard deviation is 15. And a 99.7% on that test. I don't want to label it as a percent, but you need that score to get a homework pass. All right, good luck completing the evens.